An independent system is a system of linear equations that has one solution, and that looks like basically two lines meeting, and where they meet is the solution to the system. A dependent system has an infinite amount of solutions. That's the symbol for infinity, and that would be like the system consists of one line, and then the second line is just like the other line, two lines on top of each other essentially, so an infinite amount of solutions everywhere along the points of both lines. And an inconsistent system has no solutions, and what that looks like, there's an example in your homework. Two parallel lines. Parallel lines. No solution, because nowhere do the lines intersect. The lines never intersect. So that's why there's no possible value that will be true for both lines. No ordered pair true for both lines. Now in these examples here, you're going to have to convert basically both the lines that you see into y equals mx plus b format. This should be review. This is slope, y-intercept, and we're going to have to do some math here. So the first thing we have to do is subtract 5x from both sides. You're going to get 2y is equal to 14 minus 5x, and then from here divide everything by 2. So you get y is equal to negative 5 halves x plus 7. And so let's plot this line now. We have a y-intercept of 7. It's a negative 5 halves, so it's going downhill. This is going downhill. Down 5, 1, 2, 3, 4, 5 over 7. That's right in here somewhere. Let's see. There you go. Oh, not 7, it's 5 halves. But not 5/7. Let me erase that. So it's down 5 over 2. Down 5, 1, 2, 3, 4, 5 over 2. Down 5, 1, 2, 3, 4, 5 over 2. So there's that line. And now this line, let's do it in a different color. How about red? Okay, so you'll have to add 5x to both sides. When I do that, I get 5x minus 35 is equal to 7y. From here, divide everything by 7. You get y is equal to 5/7 x minus 5. So then let's find the y-intercept. It's at minus 5. 1, 2, 3, 4, 5. And then our slope is positive. It's going to be up 5 over 7. So there's that line. And they actually don't meet at an exact coordinate. The coordinate that they meet, though, is basically approximately 4, -2. So they don't always meet on perfect integer values, but the closest point is 4, -2. Now let's go on to the next page, because this is going to be the same thing. Essentially, it's going to meet, but not exactly at a whole number value. Let's take a look at these word problems. If Rusty burns 6 calories per minute swimming and 10 calories per minute jogging, In the morning, Rusty burns 175 calories walking. Notice how walking is not the same as swimming or jogging. So it's going to be basically y is equal to 175 plus something, plus he swims for 10 minutes. Swims, so plus 6x. And then the other equation, let's see, how many minutes must he jog to burn at least as many calories, y, in the afternoon as he did in the morning? So this represents the morning. And then, sorry about that. The other one wants to know when these two lines will be equal. And he's doing now is jogging. So he jogs at 10 calories. So this is a line, this is the afternoon. So if y is equal to 10x, this first line plots very simply. Start at the origin. This is 10, 20, 30, 40, 50, 60, 70, 80, and 90. Right? And then it's just up 10. This is the afternoon. The second one is 175. So let's do, this is 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. And let's pick a different color. How about blue? So this one's going to start at like 175, which is right around there. And it goes up 6. And one thing you can do is you can figure out, well, what's the point at 100 when x is 100? You can have 600 plus 175. That's 775. So it's going to end right around there. And hopefully you can see right around here the two lines meet. So it works out to be another way you can do to solve this, to find out exactly what it is make the lines equal to each other. And now solve for x. Now I've basically got these two lines and I've set them equal to each other. What is the value of x where they'll both be equal? Once I find that out, I can substitute that in for y. So let's subtract 6x from both sides. You're going to get 4x is equal to 175. And then from here, I just divide by 4. 175 divided by 4 winds up being 43.75 minutes. So after 43.75, or approximately 45 minutes, is how long he'd have to jog to burn the same amount of calories he burned walking. So that's enough for these examples. We're going to skip this one. And now let's go to the more of the problems from the homework packet.